Let's try one more. This one's going to be even a little bit more eclectic, an eclectic one, because this one looks like this. X equals 3 plus square root of 3 minus x. Okay, now let me tell you why this is eclectic. You're saying, gee, it looks like the exact same thing as the other one. Well, let's just think through this. You see a square root, so your initial reaction should be, dink, I'm going to square both sides. Okay, that's a great reaction, but let's just think through this together and reason together. When I square this side, this is actually a binomial. There are two terms here. So when I square that out, I'm going to actually have to do a little bit of foiling. And when I start foiling, there's going to be inside terms and outside terms. And notice that those inside terms and outside terms are going to have square roots in it. So actually, by squaring this side, I am not going to, in fact, clean off that radical. Because remember, if I have something, a and b, and I square that, I do not get a squared plus b squared. Right? This is the #1 classic mistake, #1 on my top 10 list, the squaring mistake, right? This is not true. Remember, don't forget to FOIL. So there's middle terms, there's inside terms and outside terms, and that's going to actually contribute more square roots. So the important thing to remember here is that when I see a square root equation, what I have to do is get all the square roots by themselves. I have to isolate it so there's no foiling. So if that 3 weren't there, then if I squared that, I would just lift the radical. So how do I get rid of the 3? I'll bring that 3 over to the other side. So what I'm going to do is bring the 3 over, and I see x minus 3 equals the square root of 3 minus x. And I want you to notice what just happened there. By bringing this over, now I've isolated the square root. So when I square both sides, this will just lift. The radical will go away. You see that? So now I'm going to square both sides. On the left, I see x minus 3 squared. And on the right, the squaring just lifts the radical. So I see 3 minus x. And now I'm returning to a quadratic, which I can solve. Again, this is not just x plus 9. Remember, the number one mistake, classic mistake, is you have to FOIL out. If I FOIL this out, I'll see x squared, and then the inside term is minus 3x. The outside term is minus 3x. And so what I see is a minus 6x, and the last times the last would be a plus 9. I just FOILed. I multiplied x minus 3 by itself in my head. Wow. Okay? And this equals 3 minus x. What do? I see it's quadratic. I pull everything over to the left, set it equal to 0 on the right, and see what happens. If I move this minus x over, it becomes a plus x, and I see x squared minus 6x plus an x is a minus 5x. And then if I bring this 3 over, I have to subtract it, and so I see 9 minus 3, which is about plus 6, equals 0. So now I want to factor this and see what happens. Well, I'll put an x and an x. The positive sign here tells me they're the same sign, and this tells me they must both be negative. Two numbers that multiply to give 6 but combine to give 5, it looks like what? 2 and 3. Right? Minus 2x, minus 3x combined to give minus 5x, and minus 2 to minus 3. Great. Okay, so now what I want to do is say, okay, here we have this product, and it equals 0. So what does that mean? It means that either this equals 0 or that equals 0. And so if this equals 0, that means that x minus 2 equals 0. Or the other possibility is that x minus 3 equals 0. Okay, well, if x minus 2 equals 0, that means that x has to be 2. So in this case, we see that x would have to equal 2. So there's one solution. And what's the other solution? The other solution is if x minus 3 equals 0, which means that x would have to equal 3. So I get two solutions to the quadratic. But what about to the original question? Well, to the original question, what I have to do now is plug back and see. So let me actually do that. Let me lower this for you a little teeny bit here. So let's see. If I plug back and check, I have to see if these are going to work or not. Let's check the first one. Oh, I need to take my check font. So if I take my check font, I'm going to plug in a 2 here. If I plug in a 2, what happens? On the left-hand side, I see just 2. And the question is, does that equal, question mark, what I get when I plug in 2 on the right? So that would be 3 plus square root of, and I see a 3 minus 2. Well, what does that equal? That's 3 plus the square root, 3 minus 2 is 1. The square root of 1 is just 1. So this is 3 plus 1, which is 4. 4 equals 2? I don't think so. So in fact, this is false. So in fact, this is an extraneous root. It's a root to the quadratic, but not a root to the original answer. By checking, I saw that, in fact, this is not a root. Now, maybe, in fact, the other one's not a root, too. You know, just because you get one thing not to work doesn't mean the other one automatically works. Maybe this thing has no solutions. Always have to check. So let's plug 3 in here. 3 on the left for x would be 3. Does that equal, question mark, 3 plus square root of 3 minus 3? Well, 3 minus 3 is 0, so this is 3 plus 0. And notice that equals 3. Voila! 3 equals 3. Cha-ching! Checks. So in fact, there's one answer to this radical equation, and that's the answer x equals 3. And as always, it's party time. Okay, up next what I'll do is one more example of this where we'll have 2 square roots in the same problem. Oh my goodness, is there no stopping him? I'll see you there.